Here we have the 2013 higher level DCG paper, and we're going to look at question A4. So we have a little bit different play here on the usual skew lines questions that come up. So in the question we've been shown two lines and we've been asked, are these lines skew lines or intersecting lines? So skew lines will not cross over on the same point in plan and elevation, while intersecting lines will cross over at the same point in elevation and in plan. So all that we need to do for part A of the question is see where these lines actually meet. So what I'm just going to do, I'm going to extend on the line AB. I'm also going to extend on the line BC to see where they intersect. Now if these are intersecting lines, that point should be directly underneath it in plan, going along with the principles of orthographic projection, where points where they are in the elevation should be directly under it in plan. So I'm going to extend on here the line CD. I'm going to extend on the line AB. Now where these intersect, it should be the same point. However, as you can see, it is not. So they intersect in a different place, which means that these are not intersecting lines. These are skew lines. Take an example of two lines here, so I'm going to use two pencils. So the way you're looking at them now, you think that they're intersecting. However, if we have a different view, we can see they are not. They are skew lines, they are not meeting. Now if we do the same thing again, are these intersecting lines or skew lines? You can see that they are intersecting lines. So it is important to know the difference. So there's a point, that's just an inclined line, and a skewed line, of course, is going to be at an angle to the ground and also to the vertical plane. So part B just asks us to draw a line from point A to point C and determine the true length of that line. So I'm going to draw the line first in elevation and in plan. So that's the line AC in elevation. There's the line AC in plan. And that's really just a skew line. So we've no true length and we've no horizontal line. So the first thing that I want to do is find one of these lines which is going to be parallel with a plane. So in this case, I'm going to draw the line AC in the plan parallel with the vertical plane. So it's not going to change length. So all I'm going to do is rotate A around until it is a horizontal line in the plan. So hopefully we know by now that if we've a horizontal line in one view, we're going to have a true length in the other view. So I just found A in its new position, as I said, it has not changed. Right, so with my pencil there is the skew line. All that I'm actually doing is just rotating it, so the height is not going to change. So the length of that pencil is not changing. I'm just rotating it around. So now we have, as I said, the view, and if I just find that horizontal line in the elevation, what I will actually have is the true length in the question answered. So the new point A is brought up. So that is my horizontal line. So now A does not change in height, but it is rotating. So it just moves to a new position, but the height will remain the same. As again, I'm going to show here the top of my pencil, it's not changing height, it's just rotating, and that's all that I've done in plan. And I'm going to join C up to its new position And what we have there is the true length of the line, and that's what we've been asked to do in the question. So determine the true length of the line AC. It's going to put on some arrows, which is good practice, just to show the examiner what I actually did. So if I just show this curved line, I'm just showing here where my fingers, they're making the same movement. It is the same line, just one view is in elevation and the other is in plan.